students to understand, and we have this side in red and that side on blue because this is the high pressure, high temperature side, and the other side is a low pressure, low temperature side, and you have two components in any system that separate the high and low pressure sides, and that's the compressor and the metering device. So the compressor's job is to increase the pressure of the refrigerant in order to increase the temperature. The metering device's job is to lower the refrigerant's pressure in order to lower the temperature of the refrigerant. And so you have your low pressure, low temperature vapor refrigerant enters into a refrigerant compressor. In this case, it's a reciprocating compressor. That's what that looks like right there. And then you have on the outlet of the compressor, high pressure, high temperature vapor refrigerant. And so what happens is the high pressure, high temperature discharge gas is entering into the condenser coil where the refrigerant is going to reject its heat at. And so the refrigerant traveling through a refrigeration cycle, the whole object is it's moving heat. It absorbs the heat energy over at the indoor coil or the evaporator, and it rejects heat energy at the condenser coil. That's the job. And you are manipulating the refrigerant because you have a pressure increasing device and a pressure decreasing device. You're using air across the condenser coil in order to reject the heat from the refrigerant into the outdoor air, and you are absorbing heat energy by blowing the indoor air across that indoor coil, and then you have low temperature air on the other side. You have air, then you have a coil, and then you have the refrigerant inside. And so you have those three things happening. So you have high pressure, high temperature discharge gas traveling into the condenser coil, and then it comes out of the condenser coil as a high pressure, high temperature liquid refrigerant. So this is going to be subcooled refrigerant because it's going to allow the refrigerant to lower in temperature between here and here. So it's going to be subcooled liquid, fully in the liquid state as it travels through the liquid line service valve, as it travels through the filter dryer. And so the filter dryer's job is to absorb any water vapor in the system, and it's trying to collect that and store that so that the water vapor in the system does not mix with the refrigerant oil, which could damage the compressor electrical windings. So you got to think about that refrigerant and oil are traveling through any refrigeration system. That compressor is hermetically sealed, and so there's an electrical motor on the inside of there with electrical windings that are exposed to the refrigerant, because the refrigerant's job is not only to do this whole loop, but it's to also lower the temperature of the motor inside. It's to cool the motor. And so you can take a pressure reading right here at this service valve. You can also shut down this service valve up here at the top. The filter dryer is just to trap any moisture, but it has a limited capacity. So basically you have subcooled liquid traveling through here. It remains unchanged. So then you have the refrigerant entering into the metering device. So it's a high pressure, high temperature, subcooled liquid refrigerant entering. The refrigerant is forced to go into the inside of the piston metering device, and then it's going to lower in pressure. So then it's going to be in the low pressure liquid state. But really, as you can see, there's a little bit of light blue at the top. That is your little bit of vapor refrigerant. So what's happening is you're reducing the pressure so much that the refrigerant has a chance to expand. And so you have 80% liquid, 20% flash gas. As the refrigerant enters into the coil, it's already saturated. And saturated means liquid and vapor both exist at the same time. Anytime the refrigerant is saturated, you have a phase change occurring. And the phase change is the big secret to allowing the refrigerant to absorb heat energy from the air crossing the coil. And that is because anytime that the refrigerant is saturated where liquid and vapor exist, it's always the same temperature as it travels through the coil until, in this case, it becomes a vapor state, in the fully vapor state. Once it becomes vapor, it can then increase in temperature as the hot air is blowing across the coil. The refrigerant's going to absorb heat energy, a low pressure, low temperature vapor refrigerant exiting the indoor evaporator coil. And then you have the low pressure, low temperature vapor refrigerant re-entering into the compressor, and then the cycle starts all over again. It's also important to make sure that you also have vapor refrigerant entering in order to have vapor refrigerant exiting. So you got to remember that that compressor is a vapor compressor. You shouldn't have saturated refrigerant entering into that compressor. Saturated means there's going to be a little bit of liquid in the refrigerant, right? That would damage the compressor. So if that indoor blower motor was broken, maybe the capacitor was bad or whatever, the blower motor stopped working, that refrigerant's not going to be able to absorb any heat energy at that indoor coil, and so you're still going to have saturated refrigerant entering into that compressor, and that's going to damage the compressor. That's the basic refrigeration cycle. If you want to learn more, make sure to check out some of the resources we have over at our website at acservicetech.com. We also have